Okay, good morning. So today is all about the crossover between flowcharts and Python. I personally don't like drawing flowcharts, but the good news is that you don't have to actually draw them today. You can just move them around in Word. One of the big benefits of us doing Edexcel Computer Science, GCSE, is that we actually get to write Python code. And the other two main exam boards, people have to sit 2 exams in paper and they don't write proper Python code. We chose Edexcel because you actually get to do the practical code that actually does stuff. But we still need to do flowcharts. It's part of the GCSE and it might come up in paper 1. So what do we want to be able to do? Go from Python into flowcharts and vice versa, from flowcharts into Python code. We want to make sure we know what an algorithm is. So we've defined an algorithm as step-by-step instructions to solve a problem. Yeah, there we go. Set of instructions to complete a specific task. So flowcharts use shapes. If you think of, you're too young to remember and you're too young to watch the Terminator films, but this is called a Terminator, and the catchphrase from the Terminator films was, "I'll be back." And wherever you see a Terminator at the start, you know it's going to come back because there's going to be one at the end. You always start with a Terminator, you always finish with a Terminator. Whenever you calculate stuff, that's a process. If you're adding, subtracting, multiplying, dividing, it's a process. So that's a box, but we call it a process. Input to ask a question, output to display stuff, that's a parallelogram. And all of our boxes are connected up with lines. So let's look at an example. We asked for height and width. We did this last CT lesson. We do some process and we have some output. That's going to look like this. The Terminator comes back at the end. Our calculation, our process, input and output, and notice everything flows. The whole point of a flowchart is to see the flow through the program. Yeah, I think it's just worth getting started, really. This is CT5. Your job is just to move them into the right order, but start at the start, and you have to put in the arrows. So insert shapes and arrows, and just connect them all up, like so. So let's have a look. I haven't rearranged these yet. You should do that. I haven't put the arrows in yet. You should do that. I've just got the same stuff in here except for start and end. In Python, we don't need to put start and end. We start at the start at the top, and we finish at the end. But we do need to translate this. The process stuff in Python is exactly the same. The inputs and the outputs are slightly different. So yeah, we need to change output to print. And the thing that we print needs to go in brackets. So for user input, we don't want user, we do want input, and we put our brackets just in here. So that's translating it into Python. You can put a question in here, but we've not been given one in the flowchart, so we'll just ask like this. Then we have a runtime error if we try and run this, because we don't know what num1 is. We don't know what num1 is because we haven't asked the question yet. So just a reminder that sequence is the order that our instructions run, and it's important. So I recommend you use these keyboard shortcuts. Home, which is above your arrow keys, to go to the beginning. End to go to the end. Shift and home selects the whole line, and Control X is cut. So I can pop that up in there. So now I'm asking a question for num1. I can put a number in. But on line 2, it now doesn't know what num2 is. So I need this up here. Lovely, and I think we're all right now. Let's try 3 and 4. Doesn't quite work as expected yet. There's one bit missing. Yes, we've had a quick chat about how to do that. We get the question, we ask the question. Input is a function which returns the answer. We need to wrap that answer in brackets and say what we want to do with it, which is convert it to an integer. An integer, remember, is a whole number. So let's try again. That's better. 3 plus 4 is equal to 7. There was some discussion about the homework, about breakpoints and debugging. So if you didn't get the homework, I'd zone in now. A breakpoint is this blob in the gutter near the line numbers. It's a point where the program's going to pause. So in Thonny, you get a breakpoint by double-clicking on the line number. In Create with Code, you just click on the line number. What does that mean? It means when you get to that point, you can see what's happening. So I'm going to type in 3 and 4, And when it gets to that code here, it pauses. It's as though it breaks. Why? So that you can see the contents of all the global variables. And then you can step through line by line and create with code that's control and full stop. So I've now just run line 3, and you can see that total is a variable that stores an integer containing the number 7. And then control and full stop again. It's just run line 4 to display it here. That's what it means by breakpoints and debugging. So then we get to activity 2, and at this point you've become familiar with the basics of Python, and actually the hard part here is spotting what actually you need to calculate. So we call this an algorithm, but we call it a written description. It's describing what we need to calculate. You need to work out that as a flowchart. Start with a terminator, end with a terminator, ask all the questions for input, do all of your processes for calculations, display your output at the end, and it almost always falls into a kind of pattern. We call it an IPO pattern, input, process, output. Ask your questions for an input, perform your calculations for a process, display your outputs down at the bottom. So my top tips for creating these shapes, we go insert and shapes, and then you've got your flowchart section down here. If we get a terminator, this rounded rectangle, plop it in here, defaults to a really nasty shape. So if we get the kind of format that we want, like this one, you can just start typing. You don't need to put a text box on top, but I'll put start. The irritating thing with Word is when you put your next shape in, it's going to be a different colour. So if we get an input down here, it's a different colour. Unless you right click on the outside of your shape and go set as default shape. That means that the next time you put a shape in, to ask a question for an input, it's the same style as that one. So let's think. Develop an algorithm that asks the user how much their restaurant bill is. So ask how much the bill was. And I think it's a good idea to connect up as you go. There we go. I'm a bit of a perfectionist, so I would like the lines to be horizontal or vertical, but it's probably going to bug me because that's not going to be possible. Ugh. Irritating word. It's close enough, it'll do. So what's next? We ask them how much the percentage we want to give them as a tip. So next tip, if you hold down Control and click whilst your mouse is in the middle of the shape, it won't work. But if your mouse is over the edge of the shape on the line and hold down Control, you can drag a copy. Even better, if you hold down Control and Shift, that copy is perfectly lined up horizontally or vertically. Ask for tip percentage. And I'm not going to do any more. I think I've given you enough tips to get started. But remember, hold down Control and drag to copy your shapes. Top tip from a student. If you want to make sure that the lines are perfectly flat, you can click on Shape Format at the top. Select your arrow and then change the width to be 0 centimeters, which is absolutely lovely. Well done. So we've had a little discussion in class about how to do the calculation. What you want to try and avoid is anything ambiguous. Ambiguous means a possible double meaning. So you don't want to say something like calculate percentage because we don't know how to do that. You want to be crystal clear. We want to be really clear about the process and the calculation. So the tip is the percentage, if I can spell properly, percentage divided by 100 multiplied by the bill. At this point, we should probably be even more clear. I've said percentage. Well, what's percentage? I should probably say that here. Percentage equals user input. And then the same in here. Bill is user input. You get the idea. When you've finished all of this, I would like you to submit it, please, to Half Term 1, Algorithms and Programming 1, and that's where you can find out if there are any improvements that you can make in any of the other worksheets.